Hey guys, welcome to my stream. Actually, I realized I forgot to post this on, there's a watch people code thing here. Let me just bring that here and do this on stream. Why not? Usually copy my link here. What I usually put here. All right. The link has to be unique, so I have to always change the. This is kind of arbitrary here. Copy. So 25. And there we go. Okay, so yeah, so I was just messing around with the emulator, trying different games. It's a pretty cool one. It's kind of like a pinball game. You can like control how much of the spring you want to set, which is kind of neat. Yeah, Blue Dragon, it's pinball. Yeah, there's a Reddit for watching people code. I'm going to show that again. So basically it's Reddit watch people code, and people post links to their streams so that, you know, others can discover them and stuff like that. So yeah, so this pinball game, like, basically you can use the buttons here to, there's a pause. You can also tilt, which is kind of interesting. Let's see, I can tilt this way. Oh, and then I tilted too much. Pretty interesting to see like a pinball made with vector graphics. See if I can actually hit something. There we go. There we go. I think the collision detection is a little strange, but it's not too bad. Yeah, it kind of like goes through the geometry and stuff. It's a bit strange, like that. So yeah, so that's pinball. And another one that works is the Star Trek game. Now all of these are working with my rendering code, but I'm using still I'm on the Vectrex emulator CPU. So when I use my CPU, sometimes it doesn't work quite right, or there's still some instructions I haven't implemented. So I think these are supposed to be like Vulcan or Klingon ships or something. No, not Vulcan, Romulan. I think they're like Romulan warbirds or something. Yeah, I think there's like a shield. One of the bars at the bottom is let's see here, there. I think that's a shield. See, it uses up the little meter on the right side at the bottom of the screen. I don't know. I actually own this game on the Vectrex, and I'd played and I never quite understood what I was supposed to do with it. Blue Dragon says the spinners work nice in vector graphics. You mean for the pinball? Or for this game? Yeah, for pinball. think I suck at this game. Oh yeah, I remember this. This is like, if I go on this thing, I can go into another world. There we go. Flying mushroom. Or I'd say flying sombrero. Yeah, and then there's this ship I have to destroy, which is really tough. Man. Ready, Captain. So yeah, I'm not very good at this game. And of course, then there's just Vectrexy with nothing, and then we can play Mindstorm. Which is basically like an asteroids clone. It's actually really fun. This game was this is the one that's built in, right, into the ROM, and it's quite well done. So there's like 4 different kinds of asteroids, and obviously in the first mission it's only this one kind. Whoa. That was close. So you can teleport, but you never know where you're going to end up. So it's kind of dangerous, but it can save your skin in the last second. Okay, so then you're going to see in the next level there's going to be 3 of the asteroids from before and 1 new kind. And they kind of always do that. They introduce a new type, and so the new type is this 4th one here. And when you shoot this one, like a ninja star type of thing starts coming at you. See? So you want to be sure to either get out of its way or to shoot it. Like that. And later on, I think there's ones where they shoot at you, but it's actually homing missiles. They come right at you, so you have to destroy them. And all these stars around, basically when you destroy a ship, this one of the like sets of stars turn into the next smaller set of asteroids, or mines, I guess they're called, since it's Mindstorm. So like there's 2 little stars down here, and when if I would have shot the last medium-sized dude, those 2 would have turned into smaller versions. So that's pretty cool. Now that's using the other CPU. If I use my CPU, I'll show you what it looks like. Okay. So is this running on your CPU and graphics? So this is my graphics rendering. Now it's using my CPU, which is very close now. Part of what I'm working on is getting my CPU to be, more accurate, and fixing bugs in it. So here's one of the problems I have is with my CPU, it creates this weird set of lines downwards like this. They don't spawn, and my movement is totally messed. Like if I move to the right, like it's super weird what happens. So there's definitely something wonky going on with my suspicion is it's probably my add with carry that's not working right, or some instruction that's adding. But it's close, right? Like I can shoot in the wrong direction. So to fix this, what I did last week, two nights ago, is I did a capture of the instruction stream with my CPU here and with the other one to look for differences. And actually, I fixed a whole bunch last time. I fixed a bunch of cycle timing stuff. And now I'm at a point where I see here this, when it reaches basically at this address here, 7775, or actually, no, at 7773, there's this branch instruction, and for when my CPU, it ends up not taking the branch and continuing here. So branch not equal. So here it says branch not equal, go to PC plus 3, which would normally take us to, see here, you can see it goes to hex 778, and mine just goes to the next instruction, 775. So, you know, that looks wrong, since if we assume Vectrex is the more accurate CPU, there's something going wrong here. Now what's going wrong, I don't know. It's likely OR B here. That's my guess. That OR with B is not doing what's expected, since this branch not equal is based on the OR B before it. So that's sort of what I need to debug on this stream. But before I do that, I just wanted to do a couple of shout outs, since there's a couple of streamers who have mentioned me on their streams. So I just felt like I should do the same for them. One of them recently, because I was looking for other C++ streamers. There aren't many of them that I found anyway. There are a lot of people doing either Unity or Unreal. Of course, Unreal is C++, but a lot of people are mostly doing Blueprint in Unreal, or doing C# in Unity. But as for C++ programmers, not so many. Hey Will50, so what is Vectrex? You know what? I can tell you what the Vectrex is. So the Vectrex is this machine from 1982. So it looks like this. It's really cool. It's actually a console. You'd buy this, and you know, it was a full system. You'd stick cartridges in on the right side. You had this controller that was built into this box here with a 9-inch screen turned sideways, and what was cool about it was that it's all vector-based graphics, hence the name Vectrex. You could play 2-player games on it. You would have these cartridges that came with these screens, these overlays that added color, because it was actually black and white. And yeah, it kind of looks like this. If I just kill the sound here, see if this guy actually plays it. I'm not sure why it's going so slow. Probably OBS. Damn. What's taking up CPU here? So yeah, this guy's gonna put in a cartridge here. Not sure why it's going so bloody slow. It's not this. Yeah, so Will50 says, wow, cool, never heard of it before. Very interesting emulation challenge. Yeah, it is actually. I wrote a Nintendo emulator, a NES emulator, which I mean was also an interesting challenge, but there was so much information available for it that like this one is, the Vectrex, although a simpler system, is proving to be more challenging because of the lack of information. Like the kind of information I have for the Vectrex is mainly around, you know, how it works from a developer's perspective, but not so much in terms of what to do if you're writing an emulator. Whereas, you know, the NES has actually a lot of information on even if you were to write an emulator for it, since so many people have. So yeah, I don't know why this is going so slow, but anyway, there's nothing weird on my system, so anyway, probably just because like OBS is like saturating my bandwidth or something. But yeah, so yeah, I was saying just a couple of shout outs. So one person I wanted to call out was Pascal TLA. So that's the link here. It's PASCALTHIELE. So this guy is a C++ streamer. He's got some videos on his site. He's basically making a game engine in C++, DirectX 12 in UWP. So that's the new Windows 10 Universal Windows Platform thing. So he seems to really know his graphics stuff. It's pretty cool. And yeah, it's all C++. So definitely, if you're interested in C++ streams, that's a cool one to follow. Another one that I like is Evan Todd. He's also writing his own engine in C++, making his own game. And actually, the game looks really awesome. It's also cool graphics, 3D. So yeah, definitely worth checking out. It's just Evan Todd. Another one that I found that I liked is Wild Noob, who I think he's actually a streamer who plays games but also does programming. Yeah. So he's also making a 3D engine in C++. And finally, perhaps somebody who's fairly well known is Sean McGrath, SSS McGrath. So he has no videos here though, but he's always making cool stuff. I think what was his claim to fame again? I think I always write his name incorrectly. Is it Sean like that or Sean? Yeah, it's Sean McGrath. He's like been programming games forever, but he made Dyad, I believe. Yeah, he did. So Dyad's the video game here. So yeah, so just a couple of shout outs to people that I think are doing some cool streaming in C++ in particular. So Blue Dragon saying, other than a million tabs in Chrome, I think you're talking about the slowdowns? No, I mean, I don't know. I always have tons of tabs open and never seem to have any trouble. Like, does this one run smooth? I don't know. That was strange. So anyway, so yeah, so let's figure out what's going on here. So what I'm going to do is I'm going to switch to the Vectrex. I'm going to execute this instruction here and just take a look at the state of the flags. In fact, yeah, there was something I was thinking about from my debugger that I wanted to do. Because right now, the way it works is I have this print op function. So every time we execute an instruction, I have this series of, print an operation and then execute the instruction. Print and execute. Here I have a print op. What is this again here? Then I execute here and I actually care about the elapsed cycles, and I'm in a loop here for the number of cycles left. So what I was thinking about was how the way this works is printop is the function that kind of disassembles the current instruction at where the program counter is pointing at. And that's why when you run the debugger, you see, like, if I turn on trace and step, you can see here, this is what print operation does. Just before it executes the instruction, it prints out this line here. And now I hacked in last stream this output just before the address, which is a bit of a mess, but basically this shows you how many cycles the previous thing took. And like I said, it's a hack. I wanted to do something a bit cleaner. So I was thinking about how to do that and what I want with that. And what I was thinking is a couple things. One, I'm going to get rid of, just to show it again, I'm going to get rid of the description of the instruction, because I'm actually now fairly comfortable with the instruction set. And so having this is not really all that helpful anymore. It's like if I run for a little while, you know, I've got all this stuff on the right side. Honestly, I know I don't even look at it anymore. And it's just using up valuable real estate on my screen that I want to use now for outputting more interesting information about the instruction that just executed before I do the new line. So what I want to put here is like how many cycles the instruction took to execute. I want to put, I would like to potentially print out the values of the registers, because right now I can do an info reg here. And I think it would be neat if I could print those out, you know, maybe not all the registers, but perhaps the flags. Because the flags are kind of useful. You know, there's lots and lots of code that, for example, branch plus here, lots of instructions modify the flags registers. So I'd like to have the flags output here, and that would help me even debug this problem we're looking at right now. So Blue Dragon says it's still helpful for if someone wants to follow along though. It's true, but usually when I'm debugging this on stream, I'm pretty much saying what's going on here. You know, branch of plus, clear, you know, subtract the D register, this from the D register. So it's, you know, usually, like, it's, to be honest, it's not all that useful. And in fact, a lot of it is not even quite up to date. Like I have some mistakes in there, and there's like a to-do in my list to like go and clean them up. But frankly, it's just wasting space and time. And so let's just fix that up. See how that goes. So yeah, so like print op. So yeah, the thing for the description is here. So if I just remove that, we get rid of that. And so I was thinking is there's print op, so maybe I'll do that, and then I'll have like a print post op or something. And I'm not quite sure. I'm gonna have to like pass it information, which is okay. I've got the cycles. I can pass it the CPU registers. Let me see. If I go look at execute instruction. Yeah, I've kind of like lost the information that's available in print op. I mean, I'd have to like get it again, which kind of sucks. Let me see here, is it true? Oh no, I have access to the registers. So yeah, that's no big deal. Okay, yeah, that's cool. So let's go here. So let's do like cycles T, lapsed cycles, and const CPU registers. Actually, I'll put this first. Be more symmetric. So we'll say was it LLU I had? Yeah. So we'll do that. elapsed, so I'll save this. Try to think of a compressed way to write all this. I'll put flags. I'll do something like C for cycles. For flags, or I'll put, it's actually CC, control, again, control codes. So actually I have it here, print registers. So this prints all of them. Maybe what I can do is something like print CC. Move this up here, and we'll say actually not print CC, let's do I think I don't even need the value part here. Does this make sense? No, I guess I do. There we go. So get CC string. And then here, we'll do this. Okay. Okay, so the other thing I wanted to do here, gotta set a color for this. In case we use color mode. I've like run out of colors. Well, let's say we use the purple again, just like we were doing for comments, see how that looks. So we do this. So in this case, we will not print a new line there, but we will print it here. Because we know that the post-op will always happen after the execute instruction. So we're here. So if a trace is enabled, print the post-op with the CPU registers and the elapsed cycles. Underscore CPU registers. So let's see what this looks like. Not bad. I think I'm gonna get rid of the space. Compress it a bit more. There you go. If we turn on color, hey Alvaro, thanks for joining. So yeah, I think this is pretty cool. How you doing, man? Part of me wonders if I should just get rid of the... What if I just did something like... I mean, we pretty much know what we're looking at here. In fact, LLU, can I put like a... Nothing should really take more than 2 digits for a number of cycles for a single instruction. Do without the 0. Yeah, so we saw there was like a 10 in there. See? That lines up nicely. It's crazy, a 10 cycle instruction. Okay, so that's pretty cool. I think I'm pretty happy with that. Now let's do the capture with the cycle, the flags in there, and see if that helps us understand what's going on. So this was run with my CPU or run with Vectrex CPU. Diff here was my CPU versus Vectrex CPU 3. So I think this should work. If I remember, the capture starts happening when we see the ship go down, because that's actually the section that where I know there's a difference. I want to start with that one. Yeah, that's it. You can see how slow it's going, right? So I'm going to stop it when this is near the P. Just some visual marker to help me. So that was the right file. So that's, oh, actually I think I captured the wrong thing. Oh no, that was right. Was it? Which CPU are we using? Oh no, so it was the wrong thing. It's okay. So we'll do my CPU 3, and then we'll do the other one, and we'll diff the two. Okay, so now we'll switch to the Vectrex implementation. So let's see what this one looks like. Actually, we notice when it starts capturing, it actually does look different, the way it renders. So there's something else going on. Oh no, this is the same. I thought it looked different before. Okay, so we got the two captures. Let me just go check the timestamps on those, make sure I caught them properly. Yeah, almost the same size. Okay, so let's go beyond compare. We reload the two files. Wow. Much bigger differences than I thought. It's really interesting. See, now that we have the flags, we can really compare them. Just gonna align this up here. So like we can see, right when we start capturing, we have a different state for the half carry, where mine says that it's not set, and here it says it is set. So that's really interesting. And also, the fact that the 0 flag is different is a little disconcerting as well. So let's focus here. So what happens is that, for example, when AND A runs here, it's the same. And then here, when compare A runs, after that instruction we have, well, here we just have a different state for the half. Why would the half carry be set by a compare instruction? I mean, I know compare subtracts, but I thought it didn't affect the half carry. So this may not be a real difference that's worth worrying about, but let me just double check. So compare A. Oh no, I want to check in here. Okay, so you see how it says undefined for the half carry? So that pretty much means that we can ignore the changes here in the H So yeah, we can ignore that. But what was more disconcerting for me was the fact that we had here the 0 flag not set in the same way. So I don't know what was the instruction before this guy, but let's see if we can find another example of 0 being set differently. It looks like the way Vectrex works is that it'll set the half carry in the instructions where it considers them undefined, which I find a bit odd. Like here, subtract. Well, wait a minute. Subtract A. Let me go take a look at sub. Yeah, see, undefined. So yeah, I guess when there's an instruction that's undefined, Vectrex chooses to set it, and then I guess it remains until something actually would set it, like add with carry. This one here does take into account the half carry, so that's when it goes back to being the same on both ends. Then here, negate A, I'm gonna guess we'll see that it's probably undefined again. Yeah, not affected. See, not affected to me means it should remain, which is what I'm doing. So yeah, a bit surprising. So what we can do to help us focus is, let's ignore the half carry for now. I wonder if I can do this in Beyond Compare. So Beyond Compare is really cool, right? You can set rules and you can say ignore unimportant text. And what we could do here is maybe with a regex, I can say like, I want to find pipe space and then E or E. Yeah, the problem is I want this not to ignore. Or maybe what we'll do is we'll say ignore the first 3 for now, and let's focus, because I want to look at the Z. So FF or HH. Did that work? Yeah. See, if I switch into minor mode, then it doesn't show those guys. And then it should home in on things that matter. Not sure if I got that right, but I am finding differences here. Let me go see my rules here. Not helping too much. Jeff Ball? Oh, the name in my music ticker? You know who he is, Blue Dragon? He ran into him with Nathan at GDC this year. Really? Oh, okay. He's a musician that worked with you guys at Firebell back in the day. Oh, that's cool. So yeah, I'm always streaming music from OC Remix. So you'll see stuff like that on there. Okay, so kind of interested in this here. When we execute this instruction, it's showing us that the effective address that it evaluated to had a 0 for us at this location, but had a 3 on Vectrex when it ran it. Which probably means that the store here didn't work as expected. Because we can see here that we would be storing whatever value was on the stack plus 4 at that same location, then pulling some stuff and then loading into D the same value. That's very odd. See, what I don't know is what the value of D was when we got here. So let's see. Blue Dragon says, I could believe he'd get involved with OCR stuff. Well, yeah, I guess if you're a video game musician and you like to make, you probably like to make remixes and stuff. Okay, so right now we are we're using the Vectrex implementation. So let's set a breakpoint there. So I'm setting a breakpoint basically right there, once we are about to start the sequence. And at this point, if I come here, back into the diff, I want to see, like, do we hit 07DF beforehand? No, so that's the really the very first time we should break at 07DF, at least from this point. So let's break there, and we'll continue. Okay, so we're there at the breakpoint. Now we'll look at what's in our registers. So D has store D at S plus 4. Oh no, sorry. I hit the other breakpoint again. Okay, that's why. So I'll info break. I'll just disable the one at F5EF, F5E5. Disable. And then we'll continue. Okay, 07DF. That makes more sense. Okay, so here we can see that D has 03F8 at this point, which would make sense if we're going to store that. We're going to be storing actually 2 bytes at S plus 4. So when we restore here, we should be getting back the same value. And on my end, it looks like with my CPU, when we get here, D would have 0, and maybe zeros after that. We'll check. See, that's a very interesting difference, right? So let's see. Just trying to see here. So D is basically A and B. So we have roll A here. There's a lot of stuff that could have affected D. So here's a load B. So okay, so this pulls into B and PC. Okay, so before we investigate how those values came in there, let's just double check that when we do the same thing with my CPU, we get it to a different spot. I was just thinking that it would be useful for me to not always like switch to compile. What I'm gonna do is I'm going to make a copy of my build folder here. And I'll say here build Vectrex CPU, and I'll copy this here. So this is a version that has, right, missing the options file too, that's fine. So if we launch it from here instead, so this is the Vectrex version. So let's bring it back to where we were. Let's set this up. We want to do this. Then we want to delete 0. Yeah, let's turn on the trace and let's set a breakpoint at .07 DF. We'll do this. Breakpoint hit there. Like that. Did I not set the breakpoint? 07 DF. Yeah. 07 DF. Okay, so I guess it takes longer than I thought. No, this doesn't make any sense. .07 DF. Break on that. Continue. When we hit our breakpoint, delete it. Set a breakpoint on 07 DF, enable trace, and then continue. I like to kind of automate the steps so that I can reproduce this more easily. instruction breakpoint on 07DF. What am I missing here? What if we just say break on 07DF from the start? Oh, yeah. Okay, I know what's happening. I'm not actually running the ROM that I want to run. I'm running the built-in Mindstorm, and I actually want to be running the one we compiled when we assembled ourselves. Okay, let's do this. Now this will make a lot more sense. Bring this back. Okay. Yeah, the developed version is different. There we go. So we hit our breakpoint. What's cool now is that we actually have a trace, so we can try to follow what happened perhaps with D earlier on. Yeah, and in this one we see the 03F8. So let's leave this open. Let's go back in here. We'll switch the CPU back to mine. We'll run it. I think I might still be a few cycles off because when I look at the small text, it doesn't quite look right. Okay, so now we broke at the same point. Ah, interesting. So we have 00F8, whereas the other one has 03F8. In fact, yeah, 0F, 0C. Let's see if we can get them side by side. Yeah, there we go. Okay, we're pretty much the same though everywhere else, except for the H flag, which we know we're different on. 0 flag, see that's, yeah, that's disconcerting. Unless, you know, unless it is an operation that says undefined or undefined for Z, and Vectrex goes and sets it when that's the case. Okay, so let's see if we can understand what would have made. So this means that so the first one is A and the next one is B. So A is 03 for Vectrex and 0 for me. So let's see if we can see what's happening with A. Well, there are actually some interesting functions that modify A right above it, like roll A here. Oh, I see. Like what I'm wondering about here is there's this this pattern of doing left shift on B, like logical shift left B, and then roll A. So that's like logical shift left, and then roll, which is rotate left. Rotate left A. So what it makes me wonder is, does the shifting left of B carry into A? And is that maybe where I'm going wrong? I wouldn't think so, but let me double check. And also sign extend. Yeah, something funky is going on here. Let me just see when do we initialize the values for both B and A? So here we have a pull S into B. Sign extends which value again? Oh, it sign extends A. Okay, so oh, look at that. Sign extend takes bit 7 of B. So if bit 7 of B is not equal to 0, what a strange thing. Oh no, it's not that strange, right? Okay, if we think of A and B being, you know, these two registers next to each other, the idea is to sign extend the, you know, this in D, given a 8-bit value, we want to sign extend it into a 16-bit value. So it looks at the top bit of B, and if it's set, we want to store FF, so all ones in A. Otherwise, we just set A to 0. So that's ostensibly what we're trying to do here. So that's why we pull here a value into B at F60E. We sign extend into A. So this turns that value into a 16-bit value. Then we start doing these logical shift left on B, followed by a rotate left of A. Let's look up logical shift left and see if I got it right. So logical shift left shifts all bits of accumulator X or memory one place to the left. Bit 0 is loaded with a 0. Bit 7 of accumulator X or M is shifted into the carry flag. Okay. So if there was a high bit, it would end up in the carry flag. But then we rotate A. So let's look at rotate. Maybe rotate uses the carry bit. Rotates all bits of the operand one place left through the carry flag. This is a 9-bit rotation. Yeah. Through the carry flag. So the carry flag would end up into bit 0, and then the top bit would end up into the carry flag. So let me see, did I do that right? It's been a while. Op, roll. So I take the result, I take the current value, shift left 1, and I OR in the carry bit. So I do bring in the carry, and then I set the new carry to the original value's top bit. So that looks right. Okay, so what we'll do now And we do that here, left shift, roll A, left shift B, roll A. We store the result. Then once again, we load B. So actually, yeah, let's start from here because that's where the difference occurs. 07, D6. We'll start stepping from there and we'll take a look at all the values and we'll see what's going wrong. So this is mine. Okay. Let's change this a little bit. Rather than break at 07DF, we'll break a bit earlier, 07D6. We're going to figure this out. Okay, so 07D6. So step, load B. So B's got 7F. Carry's not set. Okay. Step. Now we sign extend. This here shouldn't really affect A, right? Because basically 7F does not have the top bit set. So that looks okay to me. And then after that, okay, then we step. So now we've done a logical shift left on B. So now what does it look like? FE. Okay, so now we do have a top bit as expected. This time when we sign we're not going to sign extend. And actually the carry hasn't been set yet. So again, if we step here, rotate left A should have had no effect. Indeed it hasn't. Now we shift left B. Now this time carry, aha. Looks like my carry flag did not get set there. Should totally have been set. Op LSL. Oh, what did I call it? I called it arithmetic. Because arithmetic is the same thing as logical in this case. Oh, did not do this right. How come? That's strange. I definitely didn't do this right. Or did I? Oh no, here it is. Yeah, CC. Okay. I've got the original value and I'm checking if the top bit is set. So this totally should have worked. Oh, I can't debug this. Okay. Let's try this in debug. It's going to be a lot slower in debug. but it's okay. This is quite slow. But I think we just made it. There we go. Okay, so we're here now. So now I could put a breakpoint on there. So there's the load B. 7F. Sign extend, which should do nothing. Because there's the first shift left. Now, here we are. So value is 7F. And sure enough, carry should remain 0 because this is 0. Top bit is 0, so that's correct. So, yeah, step. So now we're executing another one, which still, no, see this one here should set carry. And it didn't. Why? So because I have to compare not equal to 0 to set this bit? What happens when you try to set a bit flag like this one to a value like 128? I thought that would, as long as it was non-zero, I thought it would set it. Really? Curious. What I wonder is it that if you try to set a bit field to a value, it ends up setting it to the lowest bit of that value? So like that's the case for 128. It looks like it. In any case, that's the bug. I wonder if I have more of this kind of crap. I guess here it works because we're ending with the lowest one, so if it's set, it would have worked. But still. Yeah.
You take the red machines, the story ends. You wake up in your bed and believe whatever you want to. You take the blue machine, you stay in Wonderland, and I show you how deep the rabbit hole goes.
Yeah, I kind of not sure what I like. Okay, well anyway, this should fix it. So let's see. Let's see if it's fixed now. One thing I want to check is, rather than switch into debug, in this case I could have just disabled optimizations on that one function. Yeah, with like Pragma optimize off and on. Oh yeah. I'll try that. I want to see if it would have worked to be able to debug. I cannot turn optimization on the whole CPU because that's pretty much what takes the chunk right now of processing time. Well, not the full chunk. I know it's a big part is the breakpoint stuff, but it's still quite a bit slow if I don't optimize the CPU. But in this case, where we know what we want to debug, can be very useful. Okay, so we hit the breakpoint. There's our 7F, and we're gonna step. That's gonna do nothing. There's our logical shift left. So now we've got here. Let's put our breakpoint just to see what happens. Step for the rotate left, and then we hit our breakpoint. So now carry is set. We should see it here, yeah, capital C. So now we really should be okay. So let's see here what happens. We'll run until, where were we exactly on the other guy? .07 DF. A is 03. Perfect. Trying to figure out why it's not clearing. It's interesting. Thinking it's because I had a breakpoint set that's screwing up all the timing for the drawing. I really need to implement the drawing properly. This hack I have in place is making it a bit annoying. No, see, it's still messed up. Oh, there we go. Okay, so that's interesting. So that actually fixed the movement of the ship as well. So that's what that fixed. Fixed movement of the ship. So I think that code was probably the acceleration code. .07d6. So let's see if we can. Yeah, because I have the code, right? So Mindstorm, was it this one? Yeah. So form YX displacements. Yeah, this looks like speed vector and direction. This totally looks like the code used to move the ship. And since we weren't doing it right, we were not getting our 16-bit value computed correctly. Yeah, so Blue Dragon says big improvement. Yep. Let me see in release. So let's try it full speed. Okay, so there we go. So now we're definitely moving correctly. Great. So let's get some stuff checked in here. What are my diffs? What is this? I don't see that in my other diff. 670. 670. Here. Oh, because I don't have minor on. Okay. Where's the show? Visible white space. Huh. Oh, okay, I had added these with tabs last time. Okay. Alright, let's grab all of that then. CPU, we'll say fix ASL. Hey ABDCW, how's it going? Fix ASL to correctly set carry bit. Let's also get these debugger changes. You know what? I'll wait for that one. Okay, so now let's do another capture. Okay. Oh, I see here I missed when Will50 followed me. Did that actually show up on stream? Supposed to have. I have problems sometimes with the Streamlabs stuff. Anyway. Okay, so let's do another capture. This time we'll see where the two will differ. And then this time I don't have to keep building back and forth because I have two versions. Oh no, I do need to, no I don't, that's right. Yeah, that makes sense. So what we'll do is, no, not this. Oh, I just gotta follow. And I missed it. Oh, thanks string name Kyle for the follow. I don't know why I don't see these things properly on my screen here. Okay, so close this. Actually, do I really need to go to the next thing? I think maybe we can just keep looking here. No, let's do a new capture. Let's keep this clean. Okay, here. We'll grab into a new file. So we'll run into my CPU4. Let me make sure that's built. Yes. So we're going to capture the trace using my CPU again when the ship comes down, and we're going to compare that against Vectrex. Okay, so we're capturing. And there. So now we'll do the same thing. Let me open another command prompt for that. Here, let's give this a title. I'll say capture my CPU. I think that beeping is coming from the song. Yeah. Like, is that in my house? Nope. Alright, so here, instead of running okay, copy run.bat to run vecx.bat. And vecx edit. No. So here, instead of running this build, we'll run, go into Vectrexy. What's the name of that folder again? Build vecx CPU. And I don't need this. Okay, that ought to do it. Oh, pop D. There we go. Okay, so now we're going to capture with the Vectrex CPU. All right, let's see now. Yeah, so let's compare these two. It's funny how it considers this a minor difference. I don't even know what rule it's using to determine what's minor for text files. It's not like there's a concept of comments in the text file. But let's say we hide that and see what the first real difference is. Ah, okay, so that's interesting. Bring this back. Okay, so here, when we load at address C826, on mine it's 73, and on Vectrex it's 72. Let's see if C826 pops up a bit higher. No, it does not. And actually, this is pretty early on. Oh no, there's quite a few instructions. C826. Let me see what this looks like in the code. 0755. We'll look at Mindstorm. Okay. Rotate Fireball. So this is this frame variable. That's what this is referring to. So if we go look at what frame is, from the bottom, there's a C826 we were talking about. Frame counter. Okay. So it's actually a frame counter. I'm thinking here is, if this is really a frame counter, if we have some timing differences, it's possible that by the time we get here, we're not exactly on the same frame. Does that make sense? Let's see what it does with the frame counter. Gotta search. It's kind of an annoying name because we'll find it in comments everywhere. Adjust growth time. Bump explosion on even frame. Rotate fireball. Wait for frame boundary and input from controller. Okay, so this is where it clears the frame. Clear frame -1. And clear frames. Okay, so it's basically a 2-byte value. -1, eh? Surprising. This makes it look like as though frame is its address plus the one before, but normally it would be its address plus the next one. So that's a bit strange. Like the one before is this one here, or not necessarily. No, it's not. You can see here basically there's no byte specified before. Is there a C825? No. So not sure. Let's go back to where we were. Keep looking for frame. And that's it. Not seeing where the frame counter gets incremented though. Did I miss it? So here we jump to subroutine wait to wait for the frame boundary. So you would expect the frame counter to be incremented after that. Well, the good news is we can actually use a data breakpoint to see when this actually happens in this game. So let's see. I think it was watch. Set write, read, or both watch point. Let's look for a write watch point. So yeah, so that's just a watch on this address. So C826 is being watched. Looks like it gets written to quite a bit while we are not in the game just yet. So let's delete that. And let's put a breakpoint for when the game starts, which if I recall starts at when does it start again? 16? That's storage. Game code begins. Yeah, I think it skips all this. I think it starts at 16. Could it be? Or not? Power up here. We'll start at 002B. We should hit our breakpoint there. So we hit our breakpoint. Okay, I can get rid of it. And let's set back our watch point on C826 and Okay, so we just got to write at F19A. Oh. Okay, so it's the BIOS. Oh, okay. Right, the BIOS maintains a frame counter. So okay, whenever it calls wait, actually I should have realized that because this address C826 is in the BIOS's reserved piece of memory that it messes around with. Yeah, see? The BIOS housekeeping is in C800 to C87F. So C826 falls in there. If we go to the BIOS listing, C826. No? Ah. Oh, okay. So that's funny. So they set it to C826 because they were more interested only. Oh, okay, that's it. Mindstorm only cares about the low byte of this 16-bit counter, this 2-byte counter. It's actually the loop counter word here. It starts at C825, so that explains the subtracting 1 at the beginning of Mindstorm. It resets the loop counter to 0 for both the high and low byte. Then it only cares about the low byte in its logic. So it sets it just tracks a variable at C826. Okay, that makes sense. So if we look up this guy, we're gonna see that here it's kind of like the opposite. A warm start, it clears it and it's in the next byte. Here's where the incremental loop counter happens, right at wait recal. And wait recal is that wait function at F192. So if we go back from here, there's the wait recal. No, sorry, not in there. F192 in here. Frame wait. Okay, so this would increment the frame counter. Now, does it make sense that we would be off by 1? I don't think so. We should be calling the same number of waits. This is very suspicious. But I'm going to ignore that for now. I'm going to focus on what I think are probably more CPU-like errors. I have a feeling this might be related to timing issues. So I'm going to just ignore that for now. So this one's a bit more interesting. C836, which maps to vec angle, has a different value in my CPU versus Vectrex. It's a different address, C836. Vec angle. Angle for rise, run, and rotation calculation. So this is like used by functions like rise, run, angle, rise, run, index, rise, run, y, rotation functions. So C836. Okay, so here they were both 0. 0. And here we store a value that was computed in A, which then the next time we load it, for mine it was 8, whereas for the other, for Vectrex, it was 0. But then again, that might be based off of, yeah, that might be based off the frame counter. Let's see. Yeah, load A. Yeah, totally. We can see it here. Using the value from the frame counter then goes and does some shifting and stuff on it. Okay, so that would explain why it's 8 here and 0 there. So we might see like a kind of an offset now in these computations. So actually, maybe there is a bug with now that I think about it. Let me go back to the BIOS here. I'm starting to suspect that this frame counter, it's in order for this frame counter to work, it's going to need to do the kind of shifting logic and all that with the carry, and I wouldn't be surprised if we have yet a bug, another bug in there that makes it so that when when the low byte reaches FF and then we add 1 to it, let's say, for the next frame, it should go to 0, and then like the carry should carry into the upper byte. And maybe that's not quite working. And that's why we end up with an offset frame count. So let's look at that. That seems like a likely problem to explain this off by 1 here. So that was frame, what's it called again? Why isn't this finding anything? C836 was it? That's C836, C8. Oh, C825, that's it. Vec loop count. Okay, here. Okay, so here basically what it's doing is it's loading into X, into the index register X, the current vec loop count. So that's a 2-byte read. We get 2 bytes into X. Then it's using the load effective address X instruction because it's able to basically do math by adding 1 to X and storing it back in X. So that's what this instruction is supposed to do. And then it just says store it back. So yeah, it would be awfully surprising if that's not working, to be honest. Okay, so one way we could easily figure out what's going on there, we go into our print post op. You know what? Let's just print all the registers. Oh, I do want to print the cycles as well. It's going to be a long string, but it's okay. I do want to see, I think in this case it'll be really helpful to see yeah, you can see like it's stretching over 2 lines, but it's okay. What we're going to do is we're going to turn off the trace. We're going to set a breakpoint on F197. Yeah, so X got 1 here. Okay, let me do another little hack. So actually it's not this that's going to help me, but what we'll do is we'll go to our hit breakpoint. I'll just force it to print the registers when we hit the breakpoint. This way we'll just be able to debug more easily this specific problem. There we go. So now we can focus here on the X line here. Just want to see what happens when it reaches FF. Yeah. FF became, as expected, 100. Alright, so nothing funky there. Basically, the changes here, that initial change causes a cascade of differences. Oh, but see, it's interesting. C826. Let me take a look at this. If we open this file in Notepad++ and focus on all the axis, all the lines with C826 in it. Okay, so it just progresses linearly. So yeah, we're just going to keep seeing this kind of like offsetting. So actually, maybe this here is 75, 72, 73. So this is 72. We might hope to find, oh no, not 72. 73 here, we might find 73 on the other side. At 8974. Let's see. If we were to go to 8974, and just try to line that up. No. Peculiar. So, okay, let's try looking at that same series of values coming out at that address when using the Vectrex CPU. See if we notice anything different there. Nothing peculiar there. It's behaving exactly the same way. Okay, let's try this. What we'll do is, instead of capturing so late, we'll start capturing from the beginning for a while. No, we'll capture from when the game starts. Because we saw that it clears those values, right? So we might see what's going on with the frame counter this way. What was the entry again? here, 002B. So let's do info. Sorry, where's input? So now that I made changes to how the debugger looks, I will have to update that executable for Vectrex. This should be Vectrex now, right? Yeah. Let me go update the executable. Okay, so the Vectrex version has been updated. We'll update ours. Let's do another capture. So this time it should start capturing sooner than usual. I think it's capturing right now. There we go. Oh, actually I'm supposed to output it to a file. Why don't I have that in the buffer? Oh no, it's this one. Okay, let's do 5. Yeah, that's better. So if we could take a look in here, there's 5. Hmm, 60 megs. That might be a bit much. I'm gonna restart that and I'm gonna stop it as soon as we see the big ship. We don't really need to capture yet the ship. I just want to see what happens up until then. Okay. Yeah, it's a lot smaller. And now let's do that with ours, which is, yeah, this one. Is it? No, it's this one here. So what is this middle one? Let's kill that. CPU 5. Okay, we're capturing. Alright. Fairly close. Let's compare. Interesting. So actually, no real difference. Here is just because this capture is longer. So it looks like we should wait a bit more for our capture. Let's capture then a little bit more of the ship coming down. Or wait, am I? Yeah, that's right. Let's do this again. Okay, stop there. I like this jazzy tune. Have you met Sir Belmont? Nostalvania. Wow, almost the same size. Okay, I'm not trusting what I'm seeing here. I have a feeling I did not actually compile a different executable. That doesn't make any sense. One way we can determine it is just play the game, and we'll see without doing any captures if they look different. Oh yeah, you can give us a title. Capture Vectrex. That'll help. So if we just run this guy. No. Okay, let's do push D into there. So this should be the Vectrex one, which means that the game should work. Okay, so that's definitely Vectrex. Let's try it. I'll pop D here. Yeah, this is mine. Straight line of dots. And We can move, but no mines are appearing. The text is staying here. Interesting. $50 megs. Alright, let's go with that. And let's capture Vectrex. Vectrex CPU 5. Okay, so this diff should be bigger and longer to compute. Let's see. Oh, really no differences. So I mean, I guess up until there we're pretty much the same. So that's really interesting because we were noticing a difference when I was waiting until we hit a certain address and then continuing in terms of the frame timing. No, let's just capture longer. We'll let Beyond Compare crunch through a longer and larger diff and see what happens. Yeah, why not? Really interested to see what's going on. I stopped printing the flags because of the differences it was causing. I'm interested to, now I have like in the output, as you saw, instead of the flags here, I'm outputting number of cycles and all the register values. See, I never really went this far. We should have a pretty large 100 meg file. See if we have differences now. The difference between this capture and the previous is that at this point stars started to spawn, and we know there is a difference between the way our stars move and the ones that come from Vectrex, so maybe we'll see something. Hopefully. Oh. That's promising. I see some differences down here. Ah, so we're back to this. Okay, that's cool. So our program counter is definitely at a different place, which makes sense. We actually are, we end up at a different place after doing this branch not equals. So now the question is, why? 773. So see, we actually hit this guy many times before they start to differ. Branch not equals, and we always end up going to, we don't take the branch, and then we get here where we finally do take the branch here, and oh no, sorry, Vectrex takes the branch, but we do not. Let me just see what this is. 0773. This is why I chose the Mindstorm game, because we have the source code for it, which I assembled, and I have the listing, so we can actually see what's going on. So we load into B, whatever C mines is. C mines, active mine counter. So that's like the number of mines. Then we OR into B the value of min-max, maximum mines count, bump seed counter, insert new mine. Clear. So this would start off as 0, so we OR that in. And what's layer speed? Current mine layer speed. Is the mine layer on screen? Current mine layer direction, current mine layer speed. Not quite sure what it's used for, but anyway. So we load the number of mines, we OR the values of the current mine maximum and the current layer speed. So what is OR? Let me go check, because the fact that we're checking branch not equals here means we're looking at flags. So maybe there's a problem with how OR B sets flags. Wouldn't be surprised. That's what our problem is. So what did I want to check? Yeah, branch not equal, BNE. So that looks at the 0. That's pretty simple. So basically, if we load the number of mines and we OR it with these two values, branch not equals but branch of 0 is equal if the 0 flag is set, which should only happen if when we OR the two values, we end up with zeros. Let me see. B is 1. So we OR B with that address. That does not look right. This should not be value, this should be reg. Same thing for and. Yeah, this looks totally wrong. Okay, let me just double check before I make that change. But I mean, makes total sense. Yeah. Okay. This should be reg and reg. And here as well. Basically, it's if the result is set and negatives should be checking the result, not the value we read from memory. Okay, so let's try this. This might actually work. Okay, so here's hoping this actually fixes our problem. These are still straight line though. It does not look good. Ah, but look, spawning. So that definitely fixed the spawning problem. Just the mines are not being placed in the right place. But this is definitely, look at that. That's funny. The mines are all in the same. This is a very easy game now. Look at that beautiful straight line. This game is so easy. Okay, well, we're definitely getting much closer. So now we can actually play the game. Just just gotta figure out why all these... Oh! Or did I just get unmapped memory device read? At address 8000. Okay. Cool. So we definitely fixed another couple of bugs for op-and and op-or. Let me just look around and see. Because I mean, obviously I was basing this on some other functions around here where I was using value. Okay, should be fine. So let's get that checked in. Committed. CPU fix and or not setting instructions that were not setting negative and 0 flags correctly. Not setting 0. Okay. Like I'm super tempted. I should stop, but I'm super tempted to just run the capture one more time and take a look. Yeah, let's just do one more capture. I want to let it spawn some stars in their final positions, and then we'll stop the capture. So let's see. There we go. We've got a few. And a lot of them in the wrong place. One that keeps moving. Okay, that should be enough. That must be a big capture. Let's see. Yeah, 168 megs. And let's run a capture of Vectrex in a similar fashion. Little Gerudo Valley. Wow, almost the same. All right, oh, did I not put a 6 on that one? I didn't. Whoops. Okay, let me just rename it. Let's have go on compare crunch on that. Oh, there's a difference. Let's see what it is. Ah, so interesting. It has to do with the random seed, which, you know, if you think about it, is not very surprising in terms of positioning the stars. So here we're loading A at x plus 1. So let's see what are our differences here. Okay, so stop diffing. Okay, so yeah, it makes sense that D is different because D is both A and B. X is the same. Okay, everything else is the same. You know, earlier I was saying about the flags, but actually we have the flags here, so I don't know why it doesn't make a difference. Okay. C87D is our Vec random seed. Now, this guy on Vectrex has a 1, and us we have a 0. Default 3-byte random seed. Okay, so it's like the last 3 bytes of that section of RAM that the BIOS uses are for this 3-byte random seed. Three bytes, eh? Default 3-byte random seed. Load D, the random seed. Vec seed pointer. Increment the random seed. Seed is non-zero. Okay, you know what? This is a good place for me to stop. Looking at the time. So we're getting close. Next time, we'll be looking at this Vec random seed, trying to understand what this logic is supposed to be doing, and trying to figure out why our random seed doesn't look right. And to be honest, I think even Vectrex may not be getting this part right, because it's kind of odd how the stars get generated on Vectrex. Like if we run here, push D here. Like if we look at the Vectrex version, which is the one that is working better than mine right now, we'll notice that all the stars again get created only on the right side for the very first phase. See, like that. This cluster completely on the right side is very odd. And then if I kill myself here, actually kill myself, the next time it'll actually be more evenly spread. So that's, you know, unless you know, the mistake here has to do with the fact that those bytes in memory are not supposed to be 0 to begin with. I don't know. Well, I guess we'll find out. See, like once that first round is over, the spread is more even. So yeah, it seems like there's something wrong with the initial condition for the random seed, at least within my emulator. So we'll take a look at that. So yeah, guys, thanks for hanging out. We're getting closer every time. I'm gonna push this in case anyone's actually interested in looking at the code. And I should be back next week on Monday. So guys, thanks a lot, and I'll see you next time.